All right, this video is all about the postulates and the theorems, and let's just go to this guy right away. A theorem is a true statement that can be proven, or a postulate, or an axiom sometimes is referred to, is a statement that's just accepted as true without any proof. So these are things that we are just all claiming that we agree are true, and this can be proven. Like the Pythagorean theorem will come up later. That's a theorem you might have been exposed to about right triangles. It can be proven. It doesn't have to be assumed to be true. We can actually show you that it is always true. Okay, so here are some postulates and theorems, and I'm not going to get into a big difference between them. All these theorems that we're giving you are actually true. They just happen to be things that can be proven. Okay, so the 2-point postulate. Through any 2 points there exists one line, and exactly one. What that means is, if I give you any 2 points in space, okay, so let me give you this point and this point. There is only one line. It is exactly that line. There's no other line. It is unique. Once you tell me the points A and B, those 2 points determine that line, and that line is set in stone as a unique line. There's no other line that goes through those 2 points A and B. That's what that's saying, okay? The line point postulate, similar, but it says a line contains at least 2 points. So if I draw any line on here, it has to have at least 2 points. Because if I only give you 1 point, well, who says it's not this line? So this particular line has to have at least 2 points on it. Okay, so far so good. Oh, no. Okay, the line intersection theorem, we did kind of mention that. I didn't prove it, and that's okay. But if 2 lines intersect, then they intersect in exactly 1 point, right? There is only 1 point where these 2 guys intersect. Take this right here, take this line, boom. This little yellow line and this blue line, they only intersect at X. Again, A and B determine this particular line, and if this was a line, there is 2 points on it. Now, there are an infinite number of points on it, but there has to be at least 2 points to determine the line. Okay, so this kind of gets our line, our point line theorems. And then this next page kind of walks us through some line and plane postulates. Okay, first one, plane line postulate. If 2 points lie in a plane, then the line containing them lies in the plane. And whether you think that's obvious or not, I'm not sure necessarily it is. What this says is, if 2 points are in a plane, and since we know 2 points determine a specific line, if the points are in the plane, then so is the line, meaning the line is fully, meaning every point on that line is also in the plane. Okay? Line intersection theorem. If 2 lines intersect, then exactly one plane contains both lines. Okay, so let's go back to here. Draw a line, draw another line. If they intersect right here, only one plane has that. Even if I tilted that plane up, I can do this, I can make it go this way, and now, do you see how the lines are still in the plane of the page? They still intersect. Okay, so only one plane contains both lines. Okay, that's kind of this picture right here. The plane intersection postulate, if 2 planes intersect, the intersection is a line. We discussed this. I showed you a different picture on the previous video. But the blue plane, think of it as kind of slicing through all the way through the ground. The yellow plane is kind of this horizontal thing. And this slice right here where the planes intersect, that is a line. Okay? And then the last one, a point and line contained in the plane. So if a point lies outside of a line, then one plane goes through the line and the point. Okay, so X and Y form that line. Z is not collinear, meaning it is not on this line. Then there exists one plane that contains the point and the line, which really just kind of says that 3 points determine a plane. Okay, 3 points, 3 non-collinear points in this case, determine a plane. You can't draw 2 points, draw your line, and you pick a point outside that line. There's only one plane that can go through it. You can tilt it exactly the right way. So we could think about I can orient this however I want. Put that there. This is a point and this is a point. And again, if I put one more point anywhere out here, I can put the point up here, right, off the page. There's your plane, right? It would slice angle right like the blue and go through to the red. But there's only one plane. I can pick any point I want, and there's only exactly one plane. I can tilt it however I want, and I can make this plane shoom. Think about it cutting across. Okay? These are kind of, you're going to use these. We're going to take a look at some of these theorems later on, but the point, line, and plane postulates, I like the picture version more than the words. But in essence, we have 2 points determine a line. The intersection of 2 lines is a point. If we have a line in a plane, or 2 points are in a plane, then the line's in the plane, and actually that goes vice versa. If 2 lines intersect, there's only one plane that goes through those. The intersection of a plane and a plane is a line, and that 3 points determine a plane. Okay, these notes are also on Canvas. You can take a look at them, you can read them. They're not bad, and they are up there for you to look at. But you do need to know these things so you can answer questions about points, lines, and planes, whether they're multiple choice questions or true false questions, or even kind of fill in the blank.